In the last video, we learned about an algorithm called BOGO sort. The algorithm, it just sucked. As soon as the array included more than just like a handful of elements, it just became almost painful to watch BOGO sort trying to sort it out. So let's step up our game a little with an algorithm called exchange sort. So let's have a look at the animation that you can now see playing on the screen. We can immediately see that exchange sort is not random. We can clearly see that it's gradually making progress over time. The algorithm divides the array into two sections. You can see that one bar is highlighted in red. Can you see that? It's a thin red line that separates order from chaos. To the left of the red bar, there's a blue section of the array that is already sorted. To the right of the red bar, there's a white section, and it is this section that is not sorted yet. And we can see that the red bar is shrinking. It is shrinking until it has just the right size to be the next bar at the end of the sorted part of the array. Then the next bar is highlighted in red, and it also starts shrinking. Now to the right of the red bar, that is within the white section, we can see a yellow bar that is quickly traversing through this white unsorted part of the array. It is this yellow bar that causes the red bar to shrink. The exchange sort algorithm checks every single unsorted bar if it is smaller than the bar that is currently highlighted in red. If it is, the two bars are swapped. Notice that we are not changing the colors here though, so the red bar just appears to be shrinking over time. This process is now repeated until all bars wind up in the sorted part of the array. And once that happens, the bars turn green and the animation stops. We have sorted our array. In the last video, we coded BOGO sort and a function to visualize any sorting algorithm. And I said the cool thing about coding these two things separately is that later on we can just use our cool visualize function and insert any sorting algorithm. And another cool feature is that we can now store these different bits of code in separate files, such that the main file will really just import all of these other files. And our code remains very clean, very short, very compact, and each file just contains one particular task, that is one algorithm or one visualization technique. Okay, so how do we do this? Well, the first thing we'll do is we'll take all of this visualization code, and we're going to store it in a new file. So what I did here is I just saved all of this code in a file called visualize.py. So now I'm heading over to the main file, and I'm also going to take all of this BOGO sort code, create a new file, insert it all into here. I'm going to save it again. And I just saved it as a file called bogo.py. Now in the main script, we now have to import these functions. I'm just going to delete this. From BOGO, import BOGO sort, and from visualize, import visualize. Okay, now you just saw me deleting import random and import matplotlib. Now, of course, we cannot just delete these lines of code and not insert them anywhere else or somewhere else. So what we have to do is, because BOGO sort uses the random module, we'll have to import this up here. So I'm going to say import random. And the visualization function, the visualize function, uses both random and pyplot. So you'll have to import both of those things over here. So import random, and from pyplot, from matplotlib, of course, matplotlib, import pyplot. Okay. So let's just save all these files and let's see whether this works. I'm just going to set this to 3. Yeah, there we go. We have just greatly reduced the length size of the main script without compromising any of the functionality. So let's create a new script, an empty script. And I'm just going to save this. I saved it as exchange.py. And yeah, now we are ready to code the exchange sort algorithm. All right, I just copy pasted a little explanation on what it is that exchange sort does into the code here, into the script. It's kind of lengthy, but I think this is all that you'll need to really understand what it is that exchange sort does. I mean, you just saw the animation at the beginning of the video, but let's go through this numerical example here. So let's say we had an unsorted array called, not called, but including the integer values 2, 5, 4, 1, 3. Now, as I explained while I was talking about, like during the animation, exchange sort looks at the very first, or like the two first elements in our array. So it's going to compare 2 and 5. And now it's going to decide whether or not it has to make a swap. But as 5 is greater than 2, and 5 comes after 2, nothing is necessary here. So it's just going to leave the array as it is. So 2, 5, 4, 1, 3 remains 2, 5, 4, 1, 3. Now it's going to compare the first and the third element. 2 is less than 4, 4 is greater than 2, so again, nothing needs to change. Next step, again, 2, 5, 4, 1, 3, but now it's comparing the first and the fourth element, which happens to be 1. And now we can see that there is a problem. 2 is greater than 1, but comes before it in the array. So here, we now have to make a swap. We now make the swap. 1 and 2 have now changed positions. 1 is now at the very beginning of the array, and then comes 2. So now the array reads 1, 5, 4, 2, 3. And now we're going to compare the first and the fifth element. You can see how this little arrow here changes positions. First it's here, then there, then over there, and now it's in the fifth and final position of the array. We are comparing 1 and 3. They are in perfect order, so we don't have to do anything. We just copy paste this array in line 17 here. And now we start over. So now we're doing the second pass of the array. As you saw with the little arrows, the first arrow was always underneath the first element here during the first pass. Now in the second pass, this first arrow will always be underneath the second element. Okay? So we start with 1, 5, 4, 2, 3, and we compare the second with the third element. We don't have to bother with the first element because this is already sorted. So remember, the left-hand side of the array is always sorted with exchange sort, so we're not bothering with this anymore. We're just looking at the second and the third element. 5 and 4 are out of order, so we swap them to get this version of the array, 1, 4, 5, 2, 3. Now we compare the second, not with the third, but with the fourth element. So we compare 4 and 2. And again, 4 is greater than 2, but comes before it currently. So we have to swap it, such that the array reads 1, 2, 5, 4, 3. Now 2 and 3, no swap is necessary. 1, 2, 5, 4, 3. Okay, this is looking better. The first two elements have by now been sorted. Now comes the third pass. In the third pass, we start from where we left off after the second pass. We compare the third element with its right-hand side neighbor, which is the fourth element. This is a 4, and again, they are out of order, so we swap them. Then we have swapped 4 and 5, and now we compare the third element again, which is now 4, with the fifth element. Because we're within the second pass within the third pass. Okay, so this is kind of like, it's a nested loop, obviously. So we are now in the second iteration of the third iteration of the outer loop. Okay, so we're not comparing with the immediate right-hand side neighbor, but with the one after that. And again, 4 is greater than 3, so we have to make a swap. And now we have completed the first 3 passes of the outer loop. So the first 3 elements are now sorted, 1, 2, 3, and only 5 and 4 are out of order. So we enter the fourth and final pass, 1, 2, 3, 5, 4. We compare 5 and 4, we swap them, and they're now, okay, this is an error, but of course, this is just for you to see what needs to be changed here, and not because I made a mistake. No. This is now 1, 2, 3, 4, 5, and we have now sorted the array. We are all done. Okay, great. So let's get coding, and let's start by defining our new method. I'm going to call this exchange sort. And just like before with the BOGO sort, it's just going to have a single parameter, a single functional argument, which will be the array A. Okay, and just like with BOGO sort, we're going to define the local variable n as the length of the array. And now we'll have 2 loops. We'll have the outer loop, and we'll have the inner loop, which is then nested inside the outer loop. Okay, so here we can say for I in range 0 to n, and this can actually be n minus 1. So we can just type n minus 1 here. Now we have the inner loop, for j, and here it's important to note that we're not starting at 0, but at 1. Why is that? Let's just go up here. So the outer loop always starts at the first element in the first iteration, at the second element at the second iteration, but the inner loop, it never starts to the left or on the same position as the outer loop. So it's always starting next to it. So if we are within the first iteration, here we have index 0, and this is index 1. Here it's index 1 and index 2, so it's always one more, right? So we don't have to start at this, but we can start at I plus 1, and then we go until the last element, okay? So I hope that makes sense. And now we make the swap. So if a I is greater than a j, which is coming after, which is supposed to be coming after it, then we have to make a swap. So ai is swapped with a j, and just now type this in reverse order because, okay, well, let's go back. We have now made the swap. Okay, cool. So let's see whether this actually works. Okay, let's just define a array here, 1 and 4, and now I'm just going to print this, and I'm going to print, just use the exchange sort function, and then print a again. So we run this, and voila, 5, 2, 3, 1, 4, and after we applied the function, 1, 2, 3, 4, 5. So this is working. Nice. But of course, for us to be able to visualize this, we have to implement the generator thing, right? Remember, so we have to have this function not return something, but yield something. Right now, it's not returning anything. It's just sorting in place. So where do we yield? I think I'm just going to call this make swap if necessary. So I think we're going to add a new version of the array or yield something after we made a swap. Okay, so I'm just going to type yield a after we made a swap. And now we should be able to head back to the main file here and import from exchange. That's how I call the file. Import exchange sort. This is what I call the function, the new method. And now if we use this here, okay, this was very quickly. Let's add 10 here. Remember, 10 would have taken forever with the BOGO sort, but now I'm confident that this is going to work. Okay, there we go. No problem at all. It's sorting this. So let's increase this to 30. Okay, and here we go. So our animation is now really starting to take off. We're sorting an array of size 30. We have the bars of the different height here, and they're now all being sorted in perfect order. It's just going to take a couple of seconds more, and I think it's time for us to include some color, because now it's getting really interesting and we want to understand these algorithms, and we cannot really do that by having every bar in the same color. So let's add some color to this. Okay, so I'm in the visualize script where we have the visualize function. And okay, let's go down here and here, right there, line 20. This is where we create the bar chart. So let's just make this an object that we can actually tinker with, that we can, not tinker, but that we can play around with. Yeah, so let's just call this, I'm going to call this bars actually. And now let's just see whether we can actually do that. Bars, so it's going to say 10 here. And we can use a function called setColor. And I'm going to set this to red. And let's just go back to the main script. And here, let's set this to 15. Okay, this would be way too much. But let's set this to 15 and run this code. And yay, there it is. So the 10th bar is now highlighted in red. Okay, this is working quite nicely. So of course, we don't always want this to be the 10th bar no matter what. So we have to not only store the current version of the array, but also which array elements are to be highlighted in what color, right? So we have to make some changes to this yield function here because we have to yield more information. So the first piece of information that we would like to add might be the two bars that are currently, or that just have been swapped, right? So let's yield I and j. And if I'm not mistaken, no, actually we could do it like this, but later on we might also want to not highlight just a single bar, but like entire ranges of bars, so not just one bar. So I'm just going to make this a list. I mean, of course, it's just going to include this one integer, but if we make it a list, we can then also add like more elements into this. So if we not only wanted to have one bar highlighted in red, but 5 bars, we could specify all these 5 bars within this square brackets here, and then we would have all of these bars highlighted in red. And the same thing here, we would then use a different color for the second additional list. And okay, let's actually include a third one here. Because if you watched closely at the very beginning of the video when I showed this cool animation with the black background, which we will be creating in just a couple of videos. It's not much longer when we'll do that, until we'll do that. You saw that I was highlighting the sorted section of the array. So let's add this as well. Now, the array starts at 0 and all the left-hand side elements are sorted, and they are all sorted until the ith element, right? And bear in mind that, okay, the ith element not included, right? This is important. So we'll just make a list of a range object from 0 until I, and range does not include I. If we just typed it without the list, we would have created a range object that includes 0, 1, 2, 3, whatever until I, but we only can use a list object here in the visualization part. So we have to include this list command around the range command. Okay, so we're now going to yield 4 things. The array, the bars that we would highlight in the first color, red for example. Then we have a second set of numbers. These are all the bars that we want to highlight in orange. It could be any color, but we're going to use orange here. And then lastly, we'll have all the bars that we would highlight in a third color, and here we'll use, I mean, for example, green, because the bars are by default blue in Matplotlib, or if we change those to black, we could then use blue here. Whatever you want, you can just change this, right? Okay, so if we do this, we can now go back to visualize, and now here we'll have to change the following. The sorting process, it will now at each step, it will, so next A will be now kind of misleading because A, it's not just A that comes out of this next function, it's always these 4 things. So I'm just going to call this next frame maybe, next frame of the animation. And yeah, so next frame will now include not only this none thing here, but multiple things, right? So we'll have to change this. And I'm going to make this a tuple. So here, we're going to have 4 things. The frame, the first highlight, the second highlight, and the third highlight. And if we do it like this, actually we don't have to say next frame because we can just straight out unpack this tuple. So we can actually just use next A, what we had before. Sorry for the confusion here. And then we can say highlight 1. So I'm just going to call this, okay, I'm just going to type it out. Highlight 1, highlight 2, and highlight 3. Okay, so this command is getting kind of long. I'm sorry, this line is getting kind of long. If you were annoyed by that, just use H1, H2, H3 or something like that. I typically don't like that because I want everything to be like super easy to understand, but I can also understand if you don't like this long line of code. It's kind of a struggle between these two things. I'm sorry for that. Okay, where are we at? So if next A is none, we're going to break. Okay, this sounds good. And okay, so down here, we are now going to include a loop that changes the colors. So for B in, or let's just H in highlight 1, we are going to go into this bars object, select the 8th bar, and set its color to red. And then we'll do the same thing for the second color. So for H in highlight 2, just going to copy this line of code and use a different color here, namely orange. And then lastly, we'll do this once more for highlight 3, and I'm just going to use, okay, you know what, I'm just going to use green, I guess, even though it's kind of dark in Matplotlib, but I don't care at this point. And I don't know if this makes a big difference, but let's just set this to 0.01. Okay, hopefully this is now going to work. Let's run this. And yeah, there we go. Look at this. We now see the yellow bar running through the animation, and we can see how this algorithm is now getting the job done. The sorted section is over here in green, and this is the red shrinking bar that you saw from the animation at the beginning of the video. Okay, so we have now implemented exchange sort, and we have used colors and a great animation to make sure that we can really understand what's going on. There's one more thing we have to do. Remember how we just changed the visualization code? And we changed it in a pretty significant way. We introduced colors. So if we now went back here to BOGO sort and set this back to 4 because we don't want this to run forever, we are going to get an error because BOGO sort is now saying, hey, I'm just returning yield A here, right? I'm not returning, I'm yielding A, but visualize is expecting multiple things to be returned, right? So it has to have these additional yield statements here. So I'm just going to include I and J here. We don't really have to make use of the third color, so I'm just going to leave this empty. I'm going to save this, and I'm going to run this again. And BOGO sort is working again, and it's now also showing the 2 bars that have just been swapped. Okay, this is it for this video, I guess. Yeah, I hope you enjoyed this. We are now ready to use Matplotlib to visualize virtually any sorting algorithm that we want. Now I'm just going to go through a new sorting algorithm in any video. But of course, at some point, I think once I completed this first section on the very simple sorting algorithms, before we'll advance to the, I'm not going to say sophisticated ones, I'm just going to say better ones because they're faster. We'll use Matplotlib, but then we'll transition to Pygame. Thank you for watching, and see you in the next video.